Okay, so let's talk about some of the basic expectations going into the process. I'm assuming that if you're watching this video, you're trying to make a PCB kind of like this one. Okay, now this is a professionally made PCB at a board house, and as you can see, it has a very fine pitched components on here, surface mount components, some very fine pitched traces on here. These are like 6mm traces over here, and it probably has, I don't know, maybe 6 layers on it or something, okay? This is, for all intents and purposes, a very nice board, okay? And your design may call for something like this. But before we go any further, you will not get a board looking like this out of this process that we're about to show you, okay? The PCB mill is not designed to make something like this, okay? You will get a PCB out of it, but it will not be nearly as nice as this, okay? It won't have this green section over here, the solder mask that keeps the solder from running between different sections. Okay, it will not have things like this silk screen over here. Okay, it will not have plated through holes. Okay, so vias are going to have to be done by yourself. All right, so these are some basic restrictions that our process cannot replicate, but it's still useful in some senses. Okay. So let me show you what you will be getting. Instead, you're going to be getting something like this, okay? And basically what it is, you'll notice that as opposed to the PCB, this whole process kind of starts off with a large blank copper board like this one, okay? And it's just solid copper on both sides of the board, okay? And it only has 2 sides. Okay, so you can only have 2 layers of copper on there. Okay. So, what it is that's happening here is that our tooling process, what it does is it goes through and it cuts out sections around the traces that you've drawn. Okay, so that is, it isolates pieces of copper from the bulk copper. Okay, the copper clad. All right, and by doing that, it creates isolated connections between, you know, whatever 2 points you have. And these are the traces that you're going to be drawing on your design files. All right, those are the same traces that you would see over here, for example. Okay, they're much larger, much smaller here, and they're covered with solder mask here. But they're the same traces. Okay, they're the same traces that you would make on your design file, and you shouldn't have to change anything. All right, but you're going to get something like this. Now, something to consider here, and to really think about before you go any further, is that you'll notice that the system basically consists of 2 separate sheets of copper. Okay, the 2 sheets of copper are not connected to each other in any way. So if you need to make a connection from a trace that goes on top, for example, like this one right here, to the other side of copper on the back, okay, there's no real good way of doing that. Okay, because the 2 pieces of copper are not connected to each other by default. And so the only real way to do that is to run a wire from the top, okay, run a wire down there, solder it to the top trace, and then solder it to the bottom trace, okay, and that'll connect the 2. But other than that, there's no good way of doing it. All right, so that's something you need to consider. If your design has a lot of vias, okay, that take it from one layer, take the trace from one layer to the other, okay, that's going to be a problem for you because you're going to be spending a lot of time doing that by hand. Okay. The other thing that you need to consider when you're doing this is the size of the trace. All right. Most PCB houses will let you make a trace, put any 2 features up to 6 mils together. That's 0.006 inches. Okay. That's on a good day for a PCB house. Okay. The closest that we can isolate things away from each other is 11 mils. Okay, that's a fair bit larger than what you may be used to at a PCB in-house. But that's still useful for a lot of really small components that would otherwise be pretty much impossible to do by hand. Okay, so this is still useful for a lot of those things. Okay. Now, something else that you need to consider is that because, again, the traces are entirely separate, okay, from each other, from the top and bottom layers, that means if you put a component like this capacitor in there onto this trace, all right, and you want it to connect to this trace, you need to solder it to the top of the copper, okay? Soldering it to the bottom of the copper, to the bottom where you would normally do this, okay? If you had a PCB made for you, okay? You'd be able to take this and you'd be able to solder just the bottom bit of it, okay? But here you can see that that bit is actually completely isolated. That little pad is completely isolated from the bulk copper, all right? It's not connected to anything. If you solder down there, you're going to hold your component down and that's about it, all right? You're not going to get anywhere. So what you're going to have to do is you're going to have to solder to the top, okay? Now, you can either solder to the top, all right, or you can make sure that your traces connect to the opposite side, all right? So if your traces need to run like this, if you need to connect the pad of this capacitor, for example, okay, if you need to connect the pad of this capacitor to over here to the pad of this resistor, okay, that trace needs to run along the bottom, okay? So you have to think about which side is top and which side is bottom. Okay, so if I were to flip this around and put components in from the other direction, okay, then my standard soldering procedure would be okay. I could put components in from the top, and then be able to solder them from the traces at the bottom. Okay, it's something that you need to take into consideration and think about real carefully before you go print this. Otherwise, you will be sorely disappointed at what it is that you can do with small pitch components. All right, if you're doing nothing but surface mount components, it doesn't really matter because the traces are on the same side as the pads themselves. Okay, but if you're doing through-hole components, it does matter. So keep that in mind.